Is your data team spending valuable time rewriting the same transformation logic over and over? If so, at Altus, we have developed a product named Altida, which is a cost-effective metadata-driven framework designed to accelerate your data transformation process. Hi, my name is Ravi. I'm a senior managing consultant at Altus. Today, I'm going to show you how quickly you can build a simple data model from scratch using our in-house product, Altida. Before we jump into the live demo, let me give you a quick introduction to Altida. Altida is a metadata-driven framework with two core components, extract and load. Think of it as a rapid application delivery for your data pipelines. For extract, Altida provides pre-built pipeline templates, which are compatible with the most popular ETL tools like Azure Data Factory, Matillion, Talent, Databricks, Microsoft Fabric, and many more. So these pipelines, they read the instructions from a configuration table called extract meta, ingest the raw data from the source systems into data lake like Azure Blob Storage or S3, and then into your Snowflake landing and persistent zones. It uses predefined patterns such as append, full apply, delta, and merge for moving the data between your landing and persistent zones. The second core component is load, where the raw data is shaped into analytical or reporting models using transformation views or store procedures. This process is driven by another configuration table called load meta, which defines how your target data model should be built. The same pre-guided patterns, whatever we have seen in the extract meta, such as append, full apply, delta, and merge, can be leveraged for the data movement between the transformation views and your target dimension or fact tables. In summary, the entire ingestion and the transformation process is controlled just using two configuration tables, extract meta and the load meta, making the data pipeline delivery faster, convenient, and highly reusable. Now, let's move on to the live demonstration. Here is a scenario. Our data engineer has ingested the source data into this table in Snowflake. It's called cost per query. As you can see, this is a highly denormalized data set, and our task is to create a simple data model out of this. Here is the simple star schema model that we'll be building, which has one fact table and three dimension tables. The very first step in visualizing a data model is to build the transformation views, which Altida will use as an input for creating your target dimension and fact tables. I've already gone ahead and created these four transformation views because we'll be building a data model which has one fact table and three dimension tables. So we need four transformation views in total. Now that the transformation views are already built, the next step is to create entries in the load meta configuration table, which are nothing but executing four simple insert statements, which I'm going to go ahead and do now. Okay, I've created these four entries in the configuration table. While we are here, let's discuss some of the key columns in this configuration table. Source name. Source name is a logical identifier for your data model. So in real world, it could be a sales model or a marketing model. So for demonstration purposes, I just came up with this source name. Job name. Job name uniquely identifies every single entry in the load meta configuration table. So typically, we use the name of the transformation view as a job name. Job group. We want to split this data model into two job groups. Job group 1 for building the dimensions and job group 2 for building the fact tables. And job group sequence. This controls how your job groups will be executed. So in this particular instance, I want to build the dimensions first, followed by the fact table. Hence, job group sequence are set as 1 and 2. Job run sequence. This is a very important column which allows you to control the parallelization while building the data models. Because my dimension tables are independent, I want to run all these dimensions in parallel. Hence, the job run sequence is set to 0. With job group 2, we only have one fact table, so it doesn't matter whether we use 0 or 1. Job action. Job action specifies Altida how to merge the data from the input transformation view into the target dimension and the fact tables. For example, with the dim day, I want to rebuild the. Every time I build the dimension, I want to truncate the existing data and repopulate it. Hence, the job action is set as append with 1 equal to 1 in the SQL statement. With dim query, I want to build the dimension as a type to SCD, which means we want to capture the changes in the dimension. Hence, the job action is specified as delta. But whereas with the dim run plan and the fact table, we want to build them as type 1. So we don't care about capturing the changes. We just worry about the inserts and updates. Hence the job action is set to merge. Source schema name. This is where your transformation views will be residing. And the source table name. These are the name of the transformation views. Target database. When this column is left blank, the target dimension and the fact tables will be created in the same schema as your transformation views. Target schema name. This is where your target dimension and the fact tables will be created. Target table name. These are the names of my target dimension and the fact tables that Altida will go ahead and create for us. Target primary key. For date dimension, we don't need to configure the primary key because we are doing the truncate and reload every time we are building that dimension. But whereas with the dim query and the dim run plan and the fact table, because we'll be merging the data from the input transformation view into the target tables, we need to specify the primary key. So I've just configured the primary key columns in this column. And the final one is SK column name. SK stands for surrogate key. So while building these two dimensions, I want the surrogate keys to be created. So Altida will go ahead and create this column automatically for us. And the name of the column will be whatever you have configured here. And that's pretty much it from the database configuration side. Now let's move over to Azure Data Factory. Here we'll clone one of the Altida's predefined load templates. To do that, select the template, click on these three dots, select clone, and then move the clone copy wherever you want. I've already cloned this template into this particular folder and renamed the template accordingly. So now open the template and go to the parameters, and all you have to do is replace this source name with the source name that you have already configured in the extract method. And that's pretty much it. Your pipeline is ready to be run. So you just click on the debug to run your pipeline. Great. The job has completed successfully, and it took 1 minute 20 seconds to populate our data model. Now let's switch over to Snowflake to query our dimension and fact tables. Okay, so now let's validate the data in the dimension and the fact tables. So we'll first check the record counts, look at the data, make sure everything is populated correctly. So let's start with the date dimension. Yep, these are the record counts. This is how my date dimension looks like. Looks good to me. Okay, these are the record counts in the dim query table. This is how the data looks like. This is my dim run plan dimension record counts. This is how data looks like. And finally, these are the record counts in my fact table. And this is how the data looks like. Looks good to me. As you can see, we have built an entire data model in parallel fashion in less than 2 minutes without writing a single line of DDL. Before we wrap up, let's quickly discuss about logging. As the pipeline is running, Altida will log all the key operations into a centralized log table, making it easy to troubleshoot and debug. These logs can be accessed via Load Run Plan status view, where you will see every single metric that is being logged by Altida. And that's it. This concludes the demo, and thank you for watching.